In this lesson of notes, we're going to talk about complex numbers. You'll see that the first two blanks are the words imaginary and real. Imaginary numbers and real numbers, which includes the rational and irrational, make up the set of complex numbers. A complex number can be written in the form a plus bi, where a and b are real numbers, and I is the square root of -1. I is the imaginary part. Since I is the square root of -1, that means I squared equals -1, and then I cubed is -1 times the square root of -1, which is -I, and then I to the 4th is just 1 itself. So to simplify the powers of I, you need to divide whatever the power is by the number 4. Then whatever number is the remainder is the remaining power of I. So in this first one, we have I to the 22nd. So we have 22 divided by 4, which gives us 5.5. We're not worried about this whole number here. What we care about is this decimal. You should know that 0.5 is equal to 2/4. This remainder right here is what we're going to use for the power of I. So we really have I squared. We know that I squared is -1. So I to the 22nd is the same as I squared, which is -1. So your answer is -1. Next one, we have -6i to the 7th power. So again, we take 7 divided by 4, which is 1.75. 0.75 is 3/4. 3 is our remainder here. So we have I cubed, which is -I. So I cubed is -I. But don't forget, we still have this 6 out here. So we have -6 times -I. Well, negative and a negative make a positive, so your answer is 6i. Last one, we have two parts, I to the 26th and I to the 5th. So we'll take 26 divided by 4, which is 6.5, and then 5/4, which is 1.25. 0.5 equals 2/4. 2 is the remainder here, so we have the 3 out front still, I to the 2nd. I to the 2nd is equal to -1, so we really have 3 times -1 there. And then over here with this 0.25, the 0.25 equals 1/4, so 1 is our remainder there. It still has a 2 out front, so we have 2 I to the 1 power, which is just 2i. Now 3 times -1 is -3, plus this 2i from over here. So we combine this to come here, and this to come here. So your answer is -3 plus 2i. Now, how we get a complex number, an imaginary number, is by taking the square root of a negative real number. So for any positive real number a, where a is our number, the square root of -a is the same as pulling the I out front and then leaving a in your radical there. Now of course that means you're going to have to simplify the radical, and hopefully you remember how to do that. So in this first example, we're going to simplify by using the imaginary number I. So we have -8 here as the square root. Well, that again is the same as I times the square root of 8. Well, we think about what perfect square goes into 8, which is 4 and 2. The square root of 4 is 2, leaving the other 2 on the inside, so we have 2i radical 2 for our answer. Next one, the square root of -36. Again, pull the I out front, so we just have I times the square root of 36. Well, the square root of 36 is 6, so that's just 6i. And then for the last one, the square root of -12. If we have that I out there, then we just have the square root of 12 in the radical there. Simplify the square root of 12. That breaks into 3 and 4, where 4 is the perfect square. Square root of 4, of course, is 2. So we have 2i radical 3 as our answer. Alright, next part. It says again, imaginary numbers and real numbers make up the complex numbers. So complex numbers always have imaginary and real numbers and can be written in the form a plus bi, where a and b are real numbers, including 0. A is the real part, and this bi is the complex part, the imaginary part. I guess the whole thing is complex, so bi is just the imaginary part. Alright, example 2 says simplifying imaginary numbers, write the following complex numbers in the form of a plus bi. So here we just have to pick out which part's the imaginary and which part's the real. In this first example, we have the square root of -9 plus 6. Well, this part's not in the square root at all, and it's not a negative square root, so that's obviously our real part. The imaginary part is this -9. We know how to simplify that, so again we'll pull out an I, which just leaves us I square root of 9 plus 6. Well, the square root of 9 is 3, so that's 3i plus 6. Next one, we have the square root of -121 minus 7. Again, this negative square root part is the imaginary part, and this 7 is the real part. So we're going to simplify that 121 by pulling out an I. We have 121 on the inside. The square root of 121 is 11. So that part's 11i, and then bring down your -7 there. C says 7 plus the negative square root of 18. So again, 7 is your real part. That negative square root is the imaginary, so we'll pull out an I. And we have the square root of 18. Simplify the square root of 18, breaks into 9 and 2. 9, of course, being the perfect square. That's 3i with the radical 2 left on the inside. So your answer for that one is 7 plus 3i radical 2. Alright, this last part on this page says the additive inverse of a complex number. You should remember that inverse is basically the same as the opposite. So let's say we have this example of -2 plus 5i. We basically want the opposite, which is the inverse. So all we need to do is multiply the whole expression by a negative. So I have a negative of -2 plus 5i. Negative and a negative make a positive here. Negative times this positive 5i is a negative 5i. So the additive inverse of -2 plus 5i is 2 minus 5i. Let's say we have -5i. That's it. Again, additive inverse, I just take the negative of that. So the negative of -5i is just 5i. And then 4 minus 3i, again, take the negative of that. Negative times 4 is -4. Negative times -3i is positive 3i. And that's it for this first side of notes. Flip it over and go to the next video.